Good day, kids! Our subject for today is science. And today, I will discuss to you about series and parallel circuits. I am teacher Lani. Most essential learning competencies determine the effects of changing the number or type of components in a circuit. In the previous lesson, you have learned that electrical circuit has four parts: a source, light bulb, wires, and switch. You also learned that in an open circuit, electricity does not flow because there is a gap or no complete path from one end of the circuit to the other end. While in a closed circuit, the path of electricity is complete, allowing electricity to flow through it. This time, you will learn about the effects of changing the number of components in a circuit. Have you observed that in a series of Christmas lights, once one bulb is busted, the entire series of lights will not light up? Compare it with lights at home. Does it follow the same situation? For instance, when a bulb in a room is busted, will the bulbs in other parts of the house do not light up? Christmas lights and light bulbs in your house have different kinds of circuits. One is a series circuit and the other one is parallel circuit. Look at the illustrations carefully. This is an example of series circuit. Bulbs that are connected one after the other in one chain is an example of series circuit. In a series circuit, electric current flows through a single path. So, when one bulb is loosened or busted, all the other bulbs in this circuit will not light anymore. The loosened or busted bulb breaks or opens the pathway, so electricity cannot flow through. Parallel circuits. A parallel circuit, on the other hand, has light bulbs with different loops. Thus, each bulb is a part of different circuits. When one bulb is loosened, taken, or burned out, the other bulbs still light up. This is because each bulb has its own pathway. A break in one pathway does not make all the lights go out, because electricity can still flow through the other pathways. What kind of circuit do you have at home? If you turn off one bulb, what would happen if you use a series circuit in your home? All the other bulbs will be turned off because in a series circuit, there is only one path of electricity. Thus, the most appropriate circuits for homes is the parallel circuit. In such a circuit, each light and electrical device has its own path of electricity, that even if you turn off one of them, the others will still function. The activity that you are going to perform will clearly differentiate series and parallel circuits. Learning task number 1. Prepare the materials listed below. If not available, you may use other materials at home to perform the activity. You may ask the help of your parents or guardians or any adult members of the family if needed. Title: Build a circuit. Materials: 2 batteries, electric tape, aluminum foil, 2 pieces of electric wires, 1/8 illustration board. Procedures: Notes: handle the materials with care, especially the bulb. Set up A. Number 1. Design a series circuit similar to the illustration on the previous page or slides. Lay the circuit out on the illustration board. Number 2. Try removing one of the bulbs. Did the other bulbs still light up? Set up B. Number 1. Design a series circuit similar to the illustration on the previous page or slides. Lay the circuit out on the illustration board. Number 2. Try removing one of the bulbs. Did the other bulbs still light up? Questions. Number 1. What may happen if you add another bulb to both of your setups? Why? Number 2. What may happen if the filament of one of the bulbs in your first setup melts? Why? Number 3. What may happen if the filament of one of the bulbs in your second setup melts? Why? Learning task number 2. Answer the following questions. Number 1. Give instances when a parallel circuit is used and when a series circuit is used. 2. Give the advantages and disadvantages in using parallel or series circuits. Learning task number 3. Draw a heart eyes emoji inside the box each picture if it is an example of series circuit, and wow emoji if it is an example of parallel circuit. Learning task number 4. Draw an example of series and parallel circuits. Consider the rubric below in doing the tasks. Points: 5 points. The drawing represents a clear understanding of the concept. 4 points. The drawing represents a somewhat clear understanding of the concept. 3 points. The drawing represents a quite clear understanding of the concept. 2 points. The drawing does not represent the concepts learned. 1 point. The drawing lacks detail. Learning task number 5. Write a brief essay with at least 5 sentences on why it is important to carefully follow some safety precautions when using electricity. Consider the rubric below in doing the task. 5 points. The main idea stands out and is supported by detailed information. 4 points. The main idea is clear, but the supporting information is general. 3 points. The main idea is somewhat clear, but limited supporting details. 2 points. The main idea is not clear and limited supporting details. 1 point. The main idea is not clear and has no supporting details. Series circuits. Electric current flows through a single pathway. Parallel circuits. A route in which an electrical current can flow around. Learning task number 6. Read each item carefully. Choose the letter of your answer. Number 1. Mary Ann noticed that a set of 10 bulbs in her Christmas tree lights did not light up when it was turned on. What could be a probable cause of this? A. Small wires are used. B. Small bulbs are used. C. There are bulbs in the strand. D. There is one defective bulb in the set. Number 2. What will happen to the other bulbs in a series connections when one bulb is removed? The other bulbs will A. Light. B. Not light. C. Have dim lights. D. Have bright lights. Number 3. What will happen to the other bulbs in a parallel connection when one bulb is removed? A. Few bulbs will light. B. A few bulbs will no longer light. C. The other bulbs will still light. D. The other bulbs will no longer light. Number 4. Which of the following measures can prevent fire caused by electricity? A. Have a regular inspection of electrical cords. B. Avoid walking under low dangling wires. C. Touch a switch with dry hands. D. Do not leave sockets empty. Number 5. In a series connection, why do remaining bulbs not light up when one bulb is taken out of its holder? A. The other bulbs will not light. B. The other bulbs were burnt out. C. The path of electric current was renewed. D. The path of electric current became incomplete. Thank you, kids, and have a good day. I am Teacher Lani.